Hello and welcome to the video guide for the Smartphone Apps Data Management Project by the Big Data Management and Analytics Lab at UTD. This is an effort to facilitate the virtual laboratory and curriculum development for secure mobile computing. This project is funded by NSF, and it is under the supervision of Professor Lateefur Khan. This video will go over the project and its online applications. The Smartphone Apps Data Management Project explores the idea of performing traffic analysis on apps. With the recent emergence of mobile platforms capable of executing complex software and the rise of such platforms in sensitive domains such as banking, military operations, law enforcement, etc., user privacy and data security have become major concerns. The focus of this project is to identify an app by listening to its encrypted network traffic. We call this app fingerprinting. Here we see an overview of app fingerprinting. An attacker passively gathers encrypted packets, extracts features, and then uses data analytics and machine learning to predict the name of the app. In this way, the attacker can gain information that negatively affects the peace and security of the end users or the general population at large. It is important to note that the app server IP address cannot be used to reveal the name of the app, as multiple apps may be hosted on the same cloud server with the same IP. The web application tool introduced in this video has two objectives: mobile dynamic analysis and data analytics. So the first part of the project is dynamic analysis, which is performed through data collection. We build a dataset by executing 2,000 randomly selected Android financial apps and capture their network traffic. We used a Samsung Galaxy S running Android 4.3.1, but for the purposes of the web application, we demo this using an Android emulator. Each trace is collected over a 30-second period using a mirroring switch at the wireless router. The second part is data analytics. This involves using the traces collected in dynamic analysis and performing feature extraction to train a classifier that predicts an app. Once the classifier is fully trained, we can feed it an app's network traffic and it should accurately identify the app. So when you first access the website, a login screen appears. If you do not already have an account, we're going to create one now. If you do, just go ahead and enter your username and password and log in. To create an account, hit the link at the bottom of the box. Enter all your information: your first name, last name, a valid phone number. Make sure you also enter a valid email address, as this will be needed to complete your account creation. Also enter a username and password you want to use to access the website later. Make sure both of your passwords are entered in as the same, otherwise an error message will pop up. Hit the submit button when you're done. If there's any errors, it'll let you know. Hit the OK button and correct them. So in the username field, you can't have any periods. Then hit submit. If your account creation, if the fields were all valid, then a message will pop up letting you know that you need to check your email to get an access code to complete your account creation. From your email, you need to copy the access code and then paste it into that box. Hit verify, and if it was right, it'll tell you successfully created your account. Then use that same username and password you just created to log into the account. So this is the home screen. It hosts a series of tabs. The Dynamic Analysis tab covers the first phase of the project. The Data Analytics tab covers the second phase of the project. The Documentation tab has some helpful links. These two are relevant papers. And the user manual has a step-by-step guide on how to use the website or web application itself. The papers are relevant to the study itself. The About tab has some information about the project and the lab that conducted it. If you need to contact us, that's the email. The Download tab has a way to download results, but we can just look at this later. Alright, so as I said earlier, the Data Collection Dynamic Analysis tab hosts the first part of the project. Here we have a drop-down menu to select apps from. To select an app, select it in the menu and hit the Add button. You can add more than one app, but if you try to add the same app twice, it won't work. You can see the apps that you've added in this table below. Once you are done adding apps, hit the Collect button. A message will appear letting you know that the process has begun. You can see the process that occurs in the emulator's screen. Also, at this time, all buttons and tabs will become unavailable until the tests are complete. So essentially what's happening in the background and what can be seen on the live display is that the process is going to go through the apps that we selected, and in this case we only selected 2, and download individually each one, collect a 30-second trace, and then uninstall it. And this install-uninstall process occurs right then, simply to prevent any background traffic from affecting the results of the tests. So this is the process that we discussed earlier, where we talked about the mirroring switch, and this is exactly what's happening right now. So at this point, it seems as if the first app is being downloaded. And now it's opened, and a 30-second trace is going to be collected of the network traffic. Now this process doesn't take too long, but depending on the number of apps, it can add up. And when the trace is done being collected, the app will close, and the next app will be installed, and the same thing will occur, and then this app will be closed. And when I say closed, I also mean that the app is uninstalled completely. Okay, so in just a few seconds, it should go ahead and close this trace, as it does now. And then it'll open up the next one, and the next one's going to go through the exact same process, so I'm just going to go ahead and cut to the part where it's complete. Alright, so when the process is complete, a message will appear letting you know. You need to hit the OK button, and if you want the results, then go to the download folder, hit the date and time the test was completed at, and click the download button. And this will download as any other file or folder does on your machine. If you open the folder and follow the file path, you'll find the results. So this completed phase 1. The dynamic analysis part we just completed demoed how we collected traces to make our own data set. Features such as packet size, time, etc. are extracted to form these traces and are used alongside machine learning to train a classifier. Once the classifier is trained, we can use it to identify an app from its network traffic. This process occurs in the second phase, or the data analytics phase. Here, we emulate the second phase by evaluating the effect of various machine learning algorithms with different feature extraction techniques. These are all parameters for the tests we complete, and we define each of them from the number of apps to the number of testing instances. So there are 10 unique classifiers that can be selected in the classifier drop-down menu. The Panchenko classifier, for example, utilizes a support vector machine and considers features dealing with packet length, order, and size. Another classifier included is the Dyer Variable n-gram, which implements naive Bayes with trace time, burst time, and size. The newest classifier incorporated is the bidirectional classifier that adds bi-burst features. There are also 10 unique defenses to be chosen from in the defense drop-down menu. The pad to MTU defense pads the total packet size to the maximum transmission unit. Another defense, direct target sampling, modifies the appearance packet line distribution, while the traffic morphing defense utilizes convex optimization to distort the order in which packets are sent. Since this project only deals with smartphone apps at the moment, the only dataset is the Android apps dataset. So if the bidirectional classifier is selected, 7 additional features may also be selected consisting of packet size, uniburst and biburst features, etc. Remember, this can only be selected if the bidirectional classifier is selected. And to select multiple features, hold down the control button on your keyboard and hit the features. The number of apps, which refers to the total number of applications selected, may range from 0 to 2,000 because that is the total number of apps in the dataset right now. The bucket size is the size of the privacy set, and this can range from 0 to the number of apps, so it needs to be less than or equal to the number of apps. The number of trials denotes the number of trials the experiment will run, and this is limited to 100. The number of training instances is the number of training instances used per trace, and the number of testing instances is the number of testing traces used for each experiment, and these two combined need to be less than 20. So here 16 and 4 is 20. When you filled in all the fields, hit the Run button. If any is incorrect, a message will appear letting you know which ones to correct. Then hit the Run button again, and a message will appear letting you know the process has begun. So essentially what's happening here in the background is that using the Android apps dataset, 10 apps were randomly selected, the pad to MTU defense was applied to them, and they were tested under this classifier with these specific features. So when the test is complete, a message appears, hit the OK button, and to access these results, go ahead and hit the output folder this time and click download. Again, this will download as any other file or folder does. Alright, so this completes the Smartphone Apps Data Management project. We looked at a couple of features of it and we emulated this within the website. The Dynamic Analysis tab, again, covered Phase 1. Data Analytics tab covers Phase 2, and these together implement the app fingerprinting. The Documentation tab has helpful links, and if you have any questions, you can contact us with the email in the About tab, and we'll get back to you as soon as possible.